Animal infectious disease can directly endanger animal health and indirectly affect production efficiency, which hinders the sustainability of livestock production. Understanding how they interfere with this sustainability can help the professionals develop comprehensive strategies for disease control. While this investigation requires the professionals to analyze a variety of data sources, such as medical tests and financial reports, various specialized methods have been developed to process certain data types. However, investigating animal health surveillance is challenging as the collected data not only is complicated but also has missing information. To support disease outbreak investigations for animal disease, we develop a visual analytics methodology that utilizes unsupervised machine learning methods to infer the health status of an animal farm, despite the absence of its medical information. By coordinating interactive visualizations, our methodology also connects the three different perspectives to facilitate in-depth analysis. We demonstrate the functionality of our visual analytic interface with one representative case study. This case is about the swine production datasets in 2020 that involves a community of animal farms. We focus on analyzing a mycoplasma outbreak to gain a general understanding about it. In the disease outbreak view, we notice that prior to the outbreak, two animal movements may be relevant to the disease source. Indicated by the point color, we know one of them has no inference due to the lack of the data, whereas the other is inferred positive with low confidence. Meanwhile, on the geospatial map, besides the points representing the animal farms, these red icons suggest that there are recent outbreaks for the same disease, where one of them happened 8 days prior to the outbreak that is being analyzed. We can further examine if there is any relation between the two findings. By selecting a specific date in the disease outbreak view, the map now uses arrows to show the movement associated with this date. We therefore find one movement is geographically close to the other mycoplasma outbreak. Since the mycoplasma can be transmitted through the air over several miles, this suggests the possibility that the movement may be relevant to the disease source and that the surrounding area may be under the infection risk. We can also investigate the farms may be affected posterior to the outbreak. With the filter of the health status inference, we prioritize analyzing the farms with highly confident diseased inferences along with their movement. In particular, we find farm FBD has the highest confidence since it is much more closer to the disease farms in the visual summary view, which is generated from their financial information. This implies that farm FBD have similar data records to the disease farms due to their positions in close proximity. We can select farm FBD to further validate its inferences in the group characteristic view. This view shows the uniqueness of each group, which are indicated by the absolute value for contribution and then the sign for directions of data distributions. For example, in feed cost, the brown color for the disease farms suggests that their attribute values are lower compared to the healthy farms. As the gray solid line represents the record of farm FBD, we find that it is more similar to the records of the disease farms. We may hover over other data attributes for comprehensive validation. Besides the movement in the disease outbreak view, we find that there is a cross icon of farm FBD on recent dates, which represents its antibiotic administration history. Since the icon indicates that farm FBD has administered evolocin and that evolocin has been approved for mycoplasma control in swine, this insight suggests that perhaps farm FBD was aware of the disease outbreak and had taken prevention measures such as antibiotic administration. We can select other outbreaks from the outbreak selection menu and continue our investigation. Through this case study, we demonstrate the usefulness of our system to support essential analysis for disease outbreak investigations. Our methodology integrates the heterogeneous information to complement missing data, which allows the user to still carry valid analysis with limited information. Thank you for watching.